Okay, on to paper 2 then for the DEB 2020, and this is question 1, a pretty easy question. So the very first question starts off saying you need to find, they give you these 3 points on a coordinate system here, and it says find the equation of the line perpendicular to AB through its midpoint. So here's the line AB, its midpoint is probably somewhere here, and a line perpendicular to it looks something kind of like that. You need this line. So it looks to be a negative slope, because this is a positive slope. So a couple of things we need. Well, we need this midpoint first. And of course, the midpoint's pretty easy for us. Our midpoint formula is, so that's x1 plus x2 over 2 and y1 plus y2 over 2. So obviously this is given to you in your logbook, and we should always label these. I think it's a good idea. Let's go x1, y1, and let's go x2, y2. And let's put these figures in and see what we get for our midpoint. So x1, that's minus 2, x2, that's a plus 4 over 2, comma y1, which is a minus 3, y2, which is a plus 9 over 2. So we get 2 over 2, which is 1, and we get what looks to be 6 over 2, which is 3. So we know this point here, its midpoint is 1, 3. Now we need to get the equation of this line. So what do we need for an equation of a line? Well, a line equation, let's not forget, is y minus y1 equals to m times x minus x1. And again, that's given to us in our logbook. So it's always a good idea to see what we need to fill in here. Well, we need a point and we need a slope. We need the slope of this green line, which normally need 2 points to get a slope or a line equation, but we know something about it. We know it's perpendicular for A to B. So if we can get the slope from A to B, we can just get the perpendicular slope to it. So how do we get the slope from A to B? Well, the slope formula says that it's y2 minus y1 over x2 minus x1. For us, that's 9 minus y1, which is minus, now brackets minus 3 is the most common mistake I see. And x2, which is 4, minus x1, which is minus 2. So that's 9 plus 3, which is 12. That's 4 plus 2, which is 6. So that slope is 2. But of course, the perpendicular slope then is going to be, well, we know the general rule of thumb is to flip it upside down and change the sign. So to flip 2 upside down becomes a 1 over 2. It's positive, so now it goes to a negative. So that's the slope we're looking for, and this is the point we're looking for. I need to satisfy this formula. So y minus, now our new x1, y1 for this formula are these things. So y minus y1, which is y minus 3. Our slope, m, is now minus a half, and that's x minus x1, which is x minus 1. And of course, let's tidy this up a little bit. Y minus 3 minus a half x, minus by minus gives a plus a half. Let's multiply across everything by 2. 2y minus 6 equals to now minus x plus 1. Now, I think the new thing now is to kind of bring it all to one side. It used to be you had to get it in this format. But now a lot of the exam questions are looking for an ax plus by plus c, like this kind of thing. So they don't ask for either here. So actually this is a good enough answer. You could just keep going with this, but in general it's good enough to tidy up to 2 of these numbers. So let's do this format here, because it seems to be the new style now is this one. So let's bring the x over, he becomes positive. Y is already over there as a positive. And let's bring the 1 over, he's a minus. So minus 6 minus 1 is minus 7 equal to 0. And that's the first part done. Relatively very straightforward, I'd say, actually. Okay, then in part B, it says find the coordinates of the circumcenter of the triangle ABC. And it says hence like using your first part of your answer. Just to remind you what the circumcenter is, this is a construction you're supposed to know. The circumcenter is take any triangle, take the sides, perpendicularly bisect them. What does that mean? Well, a perpendicular bisector splits it in half perpendicularly at 90 degrees. So it goes through it perpendicular at 90 degrees, through the midpoint if you like. And if you do these 3 lines, you will find this little point in the middle. Now you don't actually need to do 3, 2 is fine, but I just showed you that it doesn't matter what side you use, just as long as you use 2 of them. So really, we are supposed to be able to draw it like this. And now we have to find it through coordinate geometry. You find a lot of this when you know your constructions in the Leaving Cert higher level. You'll find that you have to get them through process of coordinate geometry also. And it does come up a lot. So we already have one of the construction lines, this green dotted line here already. The perpendicular bisector A to B. I am now going to find the perpendicular bisector of A to C. So that's going to be a green line that looks like this, right? And wherever these two green lines, construction lines, cross over, that's my circumcenter. Essentially what I'm saying is, this is a line equation, this green line. This is also a line equation. I am looking for the point of intersection of these two line equations. So the first thing I need to do now is find the equation of this perpendicular bisector of AC. So it's the same process as above. But first off, we need to find the midpoint of AC. Okay? So the midpoint of AC is going to be equal to, so let's label these points. Really good practice just to always do this. So we have x1 plus x2 over 2, that's a minus 2 plus a minus 4 over 2, comma, y1 plus y2, that is a minus 3 plus a 3, and that's also over 2. And then, so minus 2 minus 4, that's going to be minus 6. So that's minus 6 over 2. Minus 3 plus 3, that is 0 over 2. So of course 2 into minus 6 goes minus 3, and of course the next point is 0. So we have the point that goes through. Now let's find the slope of A to C. And when we find the slope from A to C, we're looking for that perpendicular slope for this line. So our slope here is going to be equal to, and let's remember, it's y2 minus y1 over x2 minus x1. Killed the man. So slope y2, so 3 minus y1 minus minus 3, x2 minus x1, which is a minus 2. I really am a big fan of using these brackets because I really think this question is very easy. I mean, you're going to get caught out with small mistakes here. You're going to give away easy marks. So just always use brackets, just a good idea. 3 minus minus 3, that's 3 plus 3. Minus 4 minus minus 2, that's minus 4 plus 2, which is a minus 2. And of course that is a minus 3. And of course that will lead then to our perpendicular slope. So what's our perpendicular slope going to be? Well, we flip minus 3 upside down, we get 1 over minus 3. And we change the sign, the minus is gone. So it ends up being 1 over 3. Okay, so now we have our slope, we have our point, we now need a line equation for this stuff. So our line equation formula is y minus y1 equals to this thing, m times x minus x1. Alright, so when we do this, we look for our x1, y1. This is our new x1, y1 for this, and this is our slope, m. So we now have y minus 0 equals to m times, which is a third, x minus x1, which is a minus 3. A lot of minus is going on. A third x, and then plus 3 times a third, that's 1. Okay, so now we essentially have this stuff here. We have y is equal to that. What was the other line equation we had? Was this stuff here. I'm going to take it as that there. So x plus 2y minus 7 equals to 0. So this is L1 and this is L2 if you like here. I need the intersection of both of these lines. Now you can solve these using simultaneous equations, but what I like to do is get them both in the format where y is on his own over here. He's both singular, no coefficient, and he's positive. And that's something I always say to my class, is make sure y is singular and positive here for this. And you'll see why. So let's rearrange this to get y singular and positive. So 2y stays here. These guys come over. Minus x now and a plus 7. He's positive, but he has a 2 attached to him, so let's divide across by 2. And we get this stuff going on. Okay, so now I have my L2 here, where y is singular and positive. I want to get the point of intersection of the two of these. So for point of intersection, we always say set them equal to each other, but you can only do that if y is singular and positive. Set equal. So when you see point of intersection, essentially where are they the same? Set them equal to each other. So when I say set them equal to each other, since y is the same for both, well, this stuff here should also be the same for both. So we can say a third x, well, isn't that x over 3? plus 1 equals to minus x over 2 plus 7 over 2. So now we can find our common denominator if you like. Sometimes if you're unsure of the common denominator stuff, you can multiply everything first by 3 and then multiply everything by 2, and that'll do the same thing. So I'm just going to multiply everything by 6. 6x over 3 plus 6 minus 6x over 2, and then plus 6 times 7, that's 42 over 2. When I do all this, that goes in twice. 6 doesn't get changed. That's minus 3x, and now that's 21. Now hopefully you can see from this I can bring some stuff around. So 3x comes over, it becomes positive, gives me 5x over here. 6 comes over, becomes negative. That's 21 minus 6 gives me 15. That means x must be equal to 3. So my x coordinate for the intersection is 3. Well, if I have my x coordinate, I need a full x1, y1, like a full coordinate. Let's put this x back into any equation here. Let's put them into L1. So this all implies now that y is equal to, and of course this is from my L1 equation. So y is equal to a third of whatever x is, but now we know x to be 3, and plus 1. So a third of 3, that's 1, plus 1. So when x is equal to 3, it turns out that y is equal to 2. So therefore, all this says my point of intersection is x of 3 and a y of 2, and of course my point of intersection here is my circumcenter. And that's it for that question, so I hope that made sense.